For centuries, Neptune wasn't a sight. It was a calculation, a clue, a shadow that refused to be seen. Now, Webb has exposed a pattern that challenges planetary science itself. A heat pulse emerging from a region that should be dead. Not noise, not an error. A real repeating anomaly. If Neptune is running a hidden mechanism, how long has it been operating without our knowledge? Neptune has always been an enigma wrapped in frozen clouds and swirling methane storms. Voyager 2 gave us a single fleeting look in 1989. Hubble filled in a few gaps, capturing snapshots of storms rising and fading. But every glimpse raised more questions. Why is Neptune so warm inside? Why do its seasons behave unpredictably? And why do its magnetic fields twist in impossible directions? The arrival of the James Webb Space Telescope changed everything. Suddenly, Neptune wasn't just a distant blue dot. It was a world with layers, structures, and secrets that infrared eyes could finally penetrate. For months, astronomers tracked strange temperature drops, unexplained brightening near the South Pole, and subtle magnetic distortions. Then Webb recorded something no mission had ever reported. It began during a series of planned infrared passes. Routine, quiet, nothing out of the ordinary. Webb's NIR-spec instrument scanned Neptune's upper atmosphere, mapping chemical fingerprints. MIRI followed, sweeping deeper layers, reading faint thermal patterns. Scientists expected calm, stable cold zones. Instead, MIRI saw a spike, an isolated thermal surge rising from a region where temperatures should be impossibly low. At almost the same moment, NIR-spec detected unfamiliar spectral lines, chemical emissions that didn't belong there. By the third pass, the anomaly returned. Same location, same intensity, same impossible behavior. What Webb saw was not noise, it was something happening inside Neptune, something hidden beneath the clouds. There are three leading interpretations, and each one breaks the rules of planetary science. Option 1. Unexpected chemical signatures. Webb detected carbon monoxide and trace organic compounds in layers too deep and too cold to sustain them. According to every transport model designed for Neptune, these molecules should have been destroyed or frozen out long before reaching that altitude. It's as if something inside Neptune was pushing them upward, replenishing them faster than they could disappear. This suggests active mixing, possibly even an energy source no one has identified. Option 2. Heat in a forbidden zone. The tropopause on Neptune is brutally cold, around -220 degrees Celsius. Nothing should generate heat there. But Webb detected isolated warm pockets, small, concentrated pulses of thermal energy rising like plumes. Some scientists believe these could be signatures of deep convection currents pushing upward from Neptune's interior. Others suspect exotic chemistry driven by solar particles or gravitational stresses. Either way, heat should not exist here. Not at these altitudes, not at this intensity. Option 3. Magnetic field-driven energy bursts. Perhaps the most shocking possibility, Webb recorded auroral-like emissions, far from Neptune's poles. On Earth and Jupiter, auroras are tightly anchored to magnetic field lines connecting the poles, but Neptune's magnetic field is warped, tilted, and offset from the planet's center. For auroral-like signatures to appear this far from the poles, something is redirecting the magnetic field or generating charged particles deep inside the atmosphere. This discovery alone could rewrite Neptune's magnetic model. Why this breaks the rules? Neptune's internal heat shouldn't be strong enough to produce these signals. Its atmosphere shouldn't be dynamic enough to move chemicals this quickly. Its magnetic field shouldn't be flexible enough to shift energy far from the poles. The evidence points to a missing mechanism, something not included in current simulations. A dynamic layer, a buried heat engine, a chemical cycle we've never observed. We may be looking at a phenomenon we've never documented on any planet before. That's how one NASA researcher described the data in early internal briefings. Imagine seeing lightning inside the wrong layer of Earth's atmosphere, thousands of kilometers from where storms actually form, or detecting warm currents rising through solid ice in Antarctica. That's the level of contradiction Webb is revealing on Neptune. It's like the planet is rewriting its own physics. Space agencies took immediate notice. Science outlets reported anomalies, unexpected emissions, and forbidden heat signatures. Rumors of new Neptune mission concepts surfaced within weeks. The outer solar system had just become the center of scientific attention. But the anomaly may be even stranger than early reports suggest. Some scientists now believe the signals hint at internal geological activity, movement deep within Neptune's mantle. That would be nothing short of revolutionary. Ice giants were long considered geologically quiet. If Neptune is active, everything we thought we knew about these worlds changes. Others argue the sun may be responsible. We're entering a stronger phase of the solar cycle. Perhaps solar radiation is interacting with Neptune in ways we've never measured. And quietly, NASA is nervous. If Webb missed similar signals on other planets, the solar system may be far more dynamic than assumed. If you're enjoying this deep dive, consider subscribing. It helps us explore discoveries unfolding across the solar system. NASA is scheduling additional Webb observations to verify the pattern. Hubble will assist from orbit, and ground-based observatories are preparing spectroscopic follow-ups. But the real race has already begun. China's space agency is evaluating a Neptune orbiter. ESA is studying a flagship mission proposal that could include probes to descend into the deep atmosphere. Such missions would take 12 to 15 years just to arrive, but the discoveries could reshape everything we understand about distant worlds. If the anomaly holds, Neptune may reveal hidden atmospheric layers, strange heat sources, or new magnetic structures. This could finally explain its extreme winds, its uneven temperatures, and its unpredictable storms. And if Neptune hides secrets, so do the hundreds of Neptune-sized exoplanets across the galaxy. When Webb first detected that strange pulse, heat, chemistry, or energy rising from a forbidden zone, scientists assumed it was an error. Neptune had been quiet for decades, predictable, cold. But silence doesn't mean nothing is happening. Now, for the first time, the eighth planet is whispering back, revealing structures and behaviors we never imagined. Something is moving inside Neptune. Something is shifting in its atmosphere, something we've never seen on any world before. And this is only the beginning. Every time we push deeper into the solar system, our assumptions crack. The universe is not quiet. It is not still. It is alive with processes we barely understand. So the question now is simple, yet enormous. If Neptune is hiding this, what else is waiting in the dark beyond it? If you'd like to follow where this story leads next, consider subscribing. The journey into the unknown has only just begun.